I'm muted. Let me tell Thomas to join and see if he can hear. Can we do? No. Test 1, 2, 3.
I can hear you. Yeah.
Hi, Thomas.
All right, guys, we're going to be working from here, so make sure you have space to write. If you guys need to bring more chairs and like work from that table over there, feel free. Is it too dark, or are you going to be able to see what you write? Okay, because either that slide or this is dark, so is this going to be okay, or is this going to be a problem? Okay,
We can arrange the tables to make them horizontal and add more seats to them.
yeah.
I would hope so, Grace.
Make sure the tall ones are in the back. For those of you who are watching this at home, hello, we're setting up. We'll be with you shortly. So this session will be recorded, and I think your test is Thursday, right? So you'll be able to, try to take notes if you can. If not, don't worry, because you can revisit this on YouTube or in our Teams channel. But just to get you familiar real quick with what a Russell exam is, since you're going to have him for at least 3 more classes in the rest of your life. So, his tests are open book, open notes. Make sure you write your homework nicely, because most of the problems he has on the test could relate somehow to anything you did in your homework. So if you're terrible when you turn in your homework, you're going to suffer. So make sure you take good notes. It's usually 5 problems. Don't feel bad if you never finish to the 5th one. I don't think I ever did. A score in a Russell test can vary between 30 to 70, and that's pretty standard. So don't feel bad if on your first test you get a 20, or if you get a 80. It's pretty common, okay? So this is the usual cover for his test. This was my test, spring 2020. So we're gonna walk through 2 different tests. We selected 3 for problems that we think will be beneficial for you. He usually does power math. I'm not sure if you did that like the first days of class. Then he does a resistor reduction, or like you have a bunch of resistors, you combine them in series and in parallel until you just come up with one thing. We're not gonna go through that one because we know you guys are experts on that. Then he does like a source transformation where we'll go over one of those because we know those can be a little tricky. We're gonna go over a very intense name, and then a MAME with a passive active device. So if we have time.
We have not learned names.
Actually, I had the note out.
There was no name, just name?
The nodal.
We're doing it tomorrow.
I don't think it's gonna be on this day.
Oh, okay. Okay. Did he say there was gonna be MAME?
Name will be on.
Okay, so we'll do the MAME.
Also, I don't know if you did power maps.
A power map? Did he not do? A power map is where he has something like this and then a table, and then you have to fill in the values. You never did that?
No.
Okay, this is basically slow all the way till you figure. Okay, so we probably won't go over that one.
Are we gonna get it?
No. So this is a video, so the answers will be on the video if you wanna like redo them yourselves. Okay, so let's. What was it?
You want to do source transformation?
Oh, sure. Okay. Okay, so this is a usual. This was my my resistor problem. So you're welcome to later watch the video and try to attempt this problem and text me your final answer, not your work, but your final answer, and I tell you if you're right or wrong. And this is the source transformation we're gonna work today. So let's jump into it. So I would recommend you to read the question first, because I saw it wrong. I'm like, okay, let me start doing it, and I never even read the question. So just so you know what he wants, you never know if what he wants is the voltage between somewhere, and you like decompose the whole thing, and you're like, wait, what was the question again? So in this case, he wants you to find reduce the network to a single source between these two terminals, right? Okay, so any suggestions? What's the easiest thing we can do right away? Which corner, left or right? These? Okay, and what is that?
4 minus 2. 2 going upwards.
Okay, and then
And that's in 2. So we'll ignore 1.
so this is just 2 going out, right?
Yeah.
Okay, so I'm gonna.
Yeah. The 2, 6.
Okay, so we also have these here. So you guys remember your dominance?
Dominance. Yeah. That's right.
Current wins, right? So we can pretend this doesn't exist.
Parallel voltage to the voltage line.
Okay, so we can just ignore all these, and that's just it. All right, so it's looking pretty good right now.
Current source in the 6-volt series.
Okay, so
Sources could be ignored.
right, so I'm just gonna go ahead and delete them. So we are, yep.
How does scratch work in this and whatever you give the test? Like, do you just have like 8 by 11 white sheets of paper? Yes. Okay, cool.
Those 2 current sources are in parallel, so you can use repetition.
Right.
On the bottom right, there's some source dominance, so you could ignore that current source. 1 amp source.
Mm-hmm. And then,
Two fives and zero, 10.
right.
Plus there's some source dominance too.
So wait, what is 5 minus 5? And what is the 0?
Short circuit.
Okay, so all of this is short, right?
The two current sources.
Uh-huh.
You can add them, get 5 going forward.
And don't forget, this is what we want.
Got 1.5 volts. You can take out that bigger guy.
Wait,
1.5 is dominated by the current source.
right?
Series with it. 2 amp current source and 6 amp current source.
We can combine all of it. Yeah, the 5, the 6 and the 2 add up. Give you 8. Yeah, it is.
And then you,
It's 0. No. Yeah.
Yeah, great job, guys. You did it. Yeah, this is a very common Russell question. Like, he loves just giving 0 often to trick you. But that was easy, right? I'm just gonna say, so going back to like how many problems there are, usually there's 3. Let me think about these. So this one was pretty easy. This one was pretty easy. The power map is easy, but it takes a while. We won't go through it. So you can, since you didn't do name or power maps, I think you may have 3 or 4 problems on your test. Definitely the resistor, maybe a voltage divider problem. So maybe we will go through that. Yeah, either one of those. But you can expect 2 problems that you should be able to do that are very easy, right? Like your resistor and your source transformation, and then like maybe a couple problems that are actually hard, and maybe one that is impossible.
I would suggest looking through all the problems first.
Yeah.
What you can do like really well, do those problems first, and then do the rest of the others with the rest of your time. Because if you start with the hard ones, you're gonna run out of time.
Okay. Which one was the second one?
You can do your main. You do your main, your dependent source
Okay. This is the main.
on this paper.
Okay. So we're gonna do a MAME since you guys learned MAME. And this one was a lot of work. So again, one of the things that why I tell you to read the instructions is because you see this problem and you're like, oh, that's a MAME, yay! But then you're like, you finish your MAME and that's it, right? You get your currents and you're done. And he never just wants your currents. He wants you to do something with these currents. So in here, he actually wants you to find BAD. So you have to find your current values at some point. So just know he never just wants you to find your current matrix, okay? There's always something more.
That's only part A.
Yeah. So let's go ahead and get started. Another thing he will do is he will number your MAMEs for you, okay? So don't try to be brave and number them yourselves. He's already naming them for you, and he usually wants you to do clockwise. Okay? So since you're all experts on MAME, I'm gonna let you do the resistor part. And also, you guys did have problems like these, right? Where you have a dependent source?
Yeah, that's always hot.
Okay.
On the homework.
Perfect. So you're experts. You're gonna tell me what we're gonna write today. Okay, so what I like to do before I start writing my MAME is I look at my dependent sources, right? So I have this random thing here, and then I also have a dependent source here, and he's nice enough to tell me what IC should be looking like. So let's go ahead and try to get these variables in terms of mesh currents, because it's gonna make our life easier in the end, okay? So can somebody tell me what BA is in terms of mesh currents? Yeah, perfect. Good job. You're smart. You get a sticker. Remind me. Okay. So BA equals, and but wait a minute, right? So we know our polarity, right? Where the current enters, it's positive, right? So if my current is going this way. So tell me again what BA is. Yeah, perfect. And since we know the value of R1, I'm just gonna go ahead and plug it in. Right? Okay, so now let's go ahead and figure out what BV is. So BV is right here, right? That's not all the story, right? The BV is very tricky, and
All the mesh, right?
So whenever you're looking at VB, you want to, so it's a node voltage, so you're going to reference it to ground, right? So you want to see what path it takes to ground. So you start here, VB is referenced to ground, so you want this entire thing to go to ground. Or if you want to go the long ways and make it really hard for yourself, you can go like this way. But we want to take the easy route, so we want this one right here, right? So what are the voltages that add up to get you to ground here?
and then another thing, I mean, you were halfway there, but what you're not realizing is that the current, yes, if this guy is a combination between IM3.
IM3 minus IM2.
Right. Let's see. Well, let's put the polarity. We're gonna stick to this polarity. Well, no, the other one. I like to do the IM3, right? So, and once I decided this polarity for this resistor, it stays on forever, okay? If you do this here, you're gonna completely miss the whole question, okay? So stick to one. It doesn't matter which one you do, but I'm gonna select that one. So the first thing I'm gonna do is, yeah, that's gonna be negative R7, and that's IM3 minus IM2, right? Everyone agrees with that? Okay. And then what else? Let's see. So if the current is going this way, so what is my sign? Positive or negative? All right, raise your hand for positive. All right, you'll get a sticker. Good job. Who raised your hand negative? You understand why it's positive? No, you don't. You see? Okay, remember we are deciding that we're always gonna do clockwise, right? So where the current enters is positive, except we're ignoring this one. This is a special case because there's two currents and we already decided which one we're picking, right? Okay, everybody agree?
It's getting out negative.
Hmm?
It's getting out from R5 negative.
Yeah, but we're always gonna put the first sign we touch down. Sorry? For BA? Because BA is from here to ground, and the first sign I touch is the negative of the R1. Does that make sense? Yeah. Does that make sense? All right. Yeah, this is, I recommend you to go through all your homework problems where there's a MAME and practice those for the test, because like, without like, do it once and then do it again. Okay. All right, perfect. So now let's go ahead and plug in value. So we did VA. Oh, wait, but let me just plug in the actual values for these guys. So that is 6 ohms. 6 ohms. Okay. All right. Okay, so any volunteers for IC? Yep. Well, yeah, I am one, and that is because, so I am one, we're doing it this direction, and I am 4 is in this direction. So do you guys see that I am 1 will be the positive because it's in the same direction as IC, and we're subtracting I am 4 because it's in the opposite direction? Everybody comfortable with that? Okay, perfect. All right, so that is probably the hardest part about this problem, honestly. So if you can get through that yourself, you already made it. Just understanding what the dependence. Oh, come in. Welcome. We're just getting started. Yeah.
So for R7, you said the first time you touch, for R7, the first time you touch clockwise, you're gonna put it. So when you touch the positive, why for negative R7?
No, I touched the negative that I have right here. Oh, no. Here. You see that one? Does that make sense? Okay. Make sense with everyone? Okay. Okay, so like I said, if you're able to figure out your dependent values in terms of mesh currents, you're halfway there. Yeah, you can do that.
Yeah, you want to show me that? Just so like, because if someone works it a different way, because I would have worked it a different way.
And yeah, we're gonna do it the other way so you can see it's the same thing. It doesn't matter which polarity you choose, but you have to stick to it for the rest of your life, okay? If I chose this, but because I love Suzanne, I'm gonna change my polarity.
You don't have to change it for the problem. Just like showing you that even if you put the positive first,
Yeah.
you would have a different mesh current. So you'd touch the positive first, but then you'd have to do IM2 minus IM3.
Well,
so that's where it flips, and you can get the same answer. You can just pull out a negative.
Okay, so, oh wait, did I put the same thing?
Yes, you did.
Sorry.
Force habit.
Okay, so if I do it this way, right, the first thing I touch is the positive of R7, and that is IM2 minus IM3, right? Because IM2 is in the same direction of the current that I have going through R7, and IM3 will be going in the opposite direction. And then I still have my R5 IM2, and if I plug in values, then I have 6 IM2 minus 6 IM3 plus 6 IM3, which is same as before. So is it the end of the world if you chose a different polarity that I did? No. Whatever makes your life easier. Just stick to one, okay?
Yeah.
Promise me you will not choose two polarities for one resistor. Okay? All right, so now that we have our dependent sources in terms of currents, let's go ahead and write our MAME. So go ahead. Actually, I'm gonna move this to the bottom so we have space to work it out. Okay. So first of all, my MAME is gonna be how much by how much? Very smart. So what's my first loop? My first entry? Yeah, good job. And then what should I put next?
Next. Next. Go.
Actually, let me put it up here.
So what can we do with those -10, 0, and 0?
Yeah.
We also use those again? Exactly.
Perfect. All right, now give me your IM2. What else?
Next.
17? Okay.
Next.
All right, we're putting a lot of trust in this guy, guys. But
Last one, best one.
let me see if you did it right. Okay. Wait. All right, great job, guys. Great job. Okay, so what else?
What do we multiply it with? Nice. And what do we set it equal to? Let's go with IM1.
Do I need to put the dependent source
Mm-hmm.
alone and independent alone?
Yeah, so when we're first writing this out, we can keep them together. Just we'll do that in the next step. We can separate them. But for now, let's just put all the sources on the right side, and then
Yeah.
we'll separate them.
So do I put a positive or a negative? Muy bien.
Is there
Okay.
anything else in IM1? All right, next one.
Wait, here they are. Yeah, negative, right? Minus CG1 and then plus. Yep, good job. I'm gonna go ahead and put the 2 if that is okay with you guys. Yeah, I'll change the name. And then last one. Oh, you guys are doing great, regardless of my terrible looking arrows. Perfect. Okay. Okay, let me bring these back up a little bit. So now we're gonna kind of integrate our current vector into what we already have. I'm gonna leave that there for a second. So let's go ahead and decompose this guy, right? So that's gonna be -5, and then BA I said was -4 IM1. And then BB is negative of all that stuff, which is and then I'm gonna leave my EG the way it is for now. And IC we said was this. Why did I do this summation? Okay. All right, so now who wants to be brave and give me the first algebra thing? No one? Okay, 20. That wasn't that bad, was it? Okay, I'm gonna trust you. 45 what? Okay. Next, last one. Perfect. Well, we'll worry about the 0 in a second, but okay. Then here I'm still gonna keep this guy for a second. And then for the other one, it's gonna be the same but different signs, right? And then no. Okay, so now here's where we're gonna separate everything in terms of EGs and mesh current again. So now we can say that this we're gonna put this here. This equals our EG vector, which is 0, right? There's no EGs here. Then we have minus EG1 here, 0, and then plus EG1. Plus, and then our current vector. So that's going to be, we're just going to put 20, 45, -30, and then 0, right? And then okay, and then can someone give me the next line? Next one. Perfect. So we made it very far. Okay, now what do I do next? Anybody remember? Okay. Right, so who wants to give me the first column? Yeah, -2. Okay, I can guarantee you, I hope not, I hope I'm wrong, but half of you are gonna forget that when you put it on the other side, you subtract. Well, you do the negative. But I hope not. I hope you're listening to me today and thinking, I'm not gonna mess that up. How dare you? Okay, so we're finally almost there. What was the question again? Because I guarantee you forgot at this point what Russell actually wanted from me. Okay, we're almost there. And let's go ahead and plug in our values. We said it was just 2, right? Okay, let me see if we did this right. Looks good. Okay, so who wants to plug it in their calculator and see if they got it right? I mean, see if you find IM1, IM2, and IM3. You know you're being recorded, right, Suzanne?
Intermission.
This is so big. Why was the writing so big? Oh, sorry. Let me put it back on the screen. Okay. Whoever gives it to me first gets a very cool Hello Kitty sticker.
Pipes frantically.
And you have to give it to me right, of course. If you give me the wrong answer, no sticker.
Minus 0.5589 and 1700 0.1999 0.1452.
What are the units in your calculator? Well, let's look at these for a second.
He really wants that sticker, huh?
What is your answer?
I got negative 0.558873
Mm-hmm.
and then 0.170043 or 0.19952
Mm-hmm.
and then 0.1453.
Good job. Sorry,
Yeah, that's what I got.
Wait, but you said you added an extra.
I think it was in milliamps.
Yeah, you added a different.
Yeah.
Okay, I'll let you both have a sticker.
No.
Here, you can. I'll let you choose first. Even though, because he said the number weird, right? Am I tripping or did he say the
Yeah,
number
you said
weird?
weird.
So aggressive.
Okay.
It was an engineering notation. Give him a chance, guys.
Problems happen. That's how happy it came.
I think it's until
Basically, I got something at 17.
All right. Good job, guys. So you successfully did part A. Now, but what was the real question that Russell wanted? Right. So this here, which if you did these, you get 15% of the question. That's not bad, even if you forget what the actual problem was. So he wants BAD, which is BA minus BD. We know BA is this, and we know BD is this. Right, so if he wants BA minus BD, what does he actually want? Right, so what is BA? You've told me this before. Yeah. And then BD is 3 times whatever your IM2 was. Okay, so who wants to tell me what BA minus BD is? For a sticker. I don't want the stickers.
-2.631.
No. What?
She has it, she doesn't want to say.
How did this all negative 2.742.
No. Negative? No. Negative. Wait.
If
Oh,
you keep the negative on the current, then it is because the polarity, but I guess technically it would be positive. because
oh, wait.
negative.
I think we did it. What we needed to remember is the polarity of these guys. So BA is negative, right? Negative R1 times that negative current. So this guy is positive. Make sense?
Oh.
Oh. I'm talking here. All right, one more shot. Let's hear it. What is BAD?
For all the stickers, who got it?
No, just one.
1.721.
Yay! You guys did one problem. No, two, right? We said 2 problems. We are. Okay. I'm gonna let Suzanne do. What are you doing? Oh yeah. You were full, right?
Yeah.
This is it.
All right. So this is the next problem we're gonna do. So this is gonna be finding voltages using the voltage division method, right? So what do you guys think the first step here is to do?
Combine resistors.
Okay, to what point?
Node 1 to node 1.
To here? All right, so let's,
Combine everything. Right at that point, we will find it.
so let's keep this here. Let's combine this together. So what is this part right here? Can anybody give me that? Okay, 6 and then,
6 times 2 kilo ohms.
all right. We have 2K, 2K, K 12, 3K, 3K again.
If it's too thick, you can make it skinny.
All right.
4 over 5. 4.8.
Okay, at what point are we at right now? Hold on.
What do we have?
So what is this combination here? Hold on. So this is 3K, this is 3K, and we're gonna add these in series, right? And then parallel with this. Let's get to a consensus here.
Whoever says it right gets a speaker.
So we have 2K, 2K, 2K. That equals 246K, right? And that's in parallel with a 12K resistor.
It's 4. Good job, guys. You did it.
All right.
Alright, you get a speaker.
So now we're here. We still have all this 16 volts. So let's simplify this one more time. We have 3K. What's going to be this new resistor here? What?
Isn't it right?
So 6K
It's
and then
10 parallel with 10.
10 parallel with 10. That'll divide it by 2. So 5. I heard 25K.
It was fun. He was right. He knows a trick.
All right. So now we're here. And this is our V1, right? So how do we get V1?
Combine them, get current.
That's not using voltage division, guys.
16 over 8 and 5 over 5. Over 5 plus 3.
Yeah, okay, yeah. So 5K over 5 plus 3K. I'm going to just work. Exactly. Yeah. So this is the voltage division method that he wants you to use in this case, right? Now you can do it the other way using Ohm's law and all that, but this is the method he wants you to use because it's technically the easier way. You don't have to solve for current. You can just use the resistor values and move on through life. So who can give me a value for V1? What is it? 10 volts? Exactly. All right. So now that's half the problem, right? We need to now go back to our original picture. Yeah. So now we know what this voltage is right here, right? 10, this is 10 volts, right?
Yeah.
So what can we do with that known value now? Oh. Can we redraw this picture a little bit? So what I like to do is to treat that 10 volts as the source now. So let's treat that as the source and then basically replacing R2 with the voltage source. Because we now know what the voltage across that element is, so we can just treat it as a source. And then we can just start redrawing. Right? So this,
So it doesn't matter.
yeah, that resistor doesn't play any part. So now we're here, 12K, and then we start redrawing our stuff again. is the 4.7. This is the 1.3, 2, 3, blah, blah, blah. And this is 10 volts that we got, right? So now, are we going to do this? We want to find this voltage, right? So we're going to simplify this all over again, right? So what was this again? 2. All right. So we have our 10 volts, our 3K. $12. So this is 2. This is 10. Okay, next step. 6. Yep. That's 4K. Then we have this 3K. 3K. And then 10 volts. All right, so now this is, remember, our V2. Remember where we want to get to. Just have that kind of in mind. So how do we get this V2 voltage? Okay, what does that formula look like? Yep. So that's 3 plus 3 plus 4, right? Times 10. So what is V2? Exactly.
Oh, you guys are doing so good.
And that's the problem. Easy peasy, right? Piece of cake, as Russell would say. Yep. And then that's it. What's the next problem?
So you can, I remember when I did my first Russell test, it wasn't as hard as I thought it was gonna be. I was definitely more scared than in reality what it was. The test is, if you take your time and just don't miss the algebra, you should be good. It's not like impossible, but what I will say is that you run out of time pretty easily. So make sure you kind of have your notes organized, because then flipping through all your problem sets is gonna take you a while. So make sure you label everything, and make sure you know how to use your calculator. I'll say do the dependence part. Yeah, and then if we have time, we'll go to that.
This was kind of messy though.
No, I'll do the one in my test. What is the one that? The what? What's the thing you showed?
The source dominance.
Oh yeah, yeah, we'll do this one. And we'll have time after. So now we're gonna do a famous passive active Russell question, which was probably the hardest question on my test.
It's also on my test the hardest question, so if you see it, don't be alarmed if it's really hard.
Yeah, if you don't do it, don't worry. But it will be on your final. If you don't do it, it will be on your final. Just FYI.
Have you guys dealt with this problem before? Have you seen it?
It's on our home line.
Mm-hmm. So, do we know what the difference between passive and active is? What does it mean?
Active produces energy and passive dissipates it.
So what is a resistor? Very fine. Okay. So what we're trying to figure out is what is the conductance in these terminals, right? A and B. And to do that, he kind of gives you this trick of, well, just put a fake EG source. You can call it 1 or whatever. It won't matter at the end, but it will help you solve this, because what do we like that has voltage sources and meshes? Yeah, right. And that's the only thing we've learned, right? But can we do MAME with this as it is? Why? Right, so we have this nasty thing right here. So do anybody remembers source shifting? So how would this look?
split the current.
Doing balance.
Kind of bring those over.
So the way that I remember Russell explaining it to me, whenever we're doing voltage shift, it's like toothpaste. You're shifting the voltages outwards like toothpaste. But with I shift, it's like around the block. So with this, we want to go around the block. So you would kind of around like this, right? Around the block. Wow, that is not a diamond, but it is what it is. So
And then I think another thing to keep in mind is that when you're shifting a current, you want to make sure that where the current, if the this is where the current is leaving the node, and this is where the current is entering the node, right? So you want to make sure that when you do your around the block, you're doing it that way, right? So a common mistake will be like, oh, I'm just gonna flip this current, and then this is gonna go this way, this is gonna go this way, which is very wrong. Okay, so where the current leaves, it has to leave from that side too. You can do it. And we're gonna do an example for you real quick before we get. This is a intermission.
so if we, let's say, have this circuit here, have a source like this, the circuit or the resistor, and it just kind of goes on forever. So how would we get rid of this current source right here? Where would we put the current sources?
The other side of that farthest
R1,
right.
R5. So what you can do is this, right? So you have this. Where would the next one be? Mm-hmm. Going up or down? Next.
No, it's backwards. They have to be the same. Where the current enters,
I'm gonna change this.
double tap.
I was wrong. My informant told me.
Remember, you have to do the same thing. The node that it's leaving from has to stay as the node that it's leaving from, and the node that it's entering has to stay the same. So let's draw the current sources first, right?
So it must be like
Exactly.
for all.
Yeah, for all of them. So if it's leaving this node, right? It's going from here and it's leaving it. So it also has to leave this node, has to leave this node, and then it's entering this node. So at the end, you have one enter there. Does that make sense? And another way I think about this is that if I have something similar to these, I want to make sure these guys are pointing in the right direction. Sometimes you can visualize it. Like in the problem that we're working, you can see that they're both going. If you end up with the currents looking the other way, you're probably wrong.
So they all must enter the same node. Now I see.
And then I don't know if you guys understand with e-shifting. So if we have the same scenario of these resistors and we have the voltage source here, how would we get rid of that voltage source? So we shift it like this, right? So we can put resistor, voltage source, another voltage source, resistor, yada, yada, yada. Right? And then this gets replaced with a short. But in this case, this would get replaced with an open. Because that's just how current sources work in voltage sources, right? So I would just keep those two in mind. This is E shift. This is I shift. So this is, I remember him saying around the block, and this one was like squeezing toothpaste. I don't know if he still gives that analogy, but that's what I remember.
Ideally, wouldn't we source downwards to resistors?
It doesn't matter. I mean, it depends on what will make your life easier.
Okay.
Yeah, it can go to the top or to the bottom. It's whatever works best for your circuit.
But if you go to the bottom, it will be negative, right? Because the negative is the first thing touching that node.
Mhm.
And here we push the positive first. Make sense? All right, going back to, so now that we understand that, so if we look at our current again, so if we want to get rid of these, we will do the around the block, and we can do it, here if you are comfortable with, if you prefer to look at it from the bottom. Right, so it's, our current was originally leaving this node, right? So it has to leave this node as well. Oh, God. And then it wants to enter this node, right? So it should enter this node as well. And a better way to draw, I think I drew it down here better. Okay, cool. So now we know what the real circuit looks like. But are we done for our thing? All right, so now let me get a white pencil. So this doesn't exist anymore. But if I want to apply MAME, what do I need to do now? Right, so what is this guy going to look like now? So it's gonna be a resistor. It's my battery going to be, which, see, if I look at it from the left, good job. And what is this battery? What is the voltage across this battery? Right, and because one times anything is just itself, I'm just gonna write these, right? Would it be the same here? Okay, so I'm gonna have a resistor, same, and then GM times V1 plus V4. Yep, so now my problem looks like this, right? R1 is R2. Oops. Okay, so, and then we're gonna call this EG for now. But at some point we want to figure out what this is. So we can see, so do we know what GAV is? What does G stand for? Right, so in terms of Ohm's law, what would GAV be? What is and he put your current there for you. So what did he labeled that current? Yeah. And he gives it to you here in case you forgot what that is. So that's why I would like you to read your problem before you start answering. So he's like, in case you forgot what conductancy is, here you go. So anyways, so okay, so that's our goal, just in the long run. The issue here is that IA is not just IA, right? IA is IM1 minus IM2. Well, in fact, is IM2 minus IM1, right? Okay, so like I remember, I like to do my dependent sources first, and I think he gave us the value for, oh no, GM is a secret. So what is B1 in terms of mesh currents? Anyone?
Positive. Or one time.
Well, is it? Because the polarity I'm giving this resistor is this, right? Yeah, so it's negative R1 IM1. Make sense? Yeah? You look confused. You got it? No? Okay. So Russell is just labeling this voltage as B1, right? But that's not the polarity we are assigning to our resistor because, I mean, you could, but if you do MAME counterclockwise, you're not my friend anymore because that's just gross. But you could do MAME counterclockwise, but in our life, we're just going to stick to doing MAME clockwise, right? So this is a current, and the current gives you the polarity of your resistor, okay? The current will tell you which polarity your resistor is because where the current enters is. Yes. So because the current is going this way, the real polarity for my resistor is this, okay? So when I look at V1 and I'm trying to figure out what that voltage is from here to ground, the first thing I touch for my resistor is a negative. So that's why it's negative R1 IM1. Okay? Okay. So if I plug in values, that's going to be negative 2 IM1. And then, so same thing for B4. So we established that the polarity of this resistor is this and this, and then the polarity of B4 that Russell gave us is this. So what would B4 be? Yeah, perfect. So that is just IM2, right? Yeah, and that was our question.
So did you put the polarity on V1 because V1 is the opposite of what the polarity we assigned was?
Yeah.
But why can't you just put the polarity then?
You could, I just don't like to do MAME counterclockwise.
It would just be negative. Like it's the same exact thing. If you keep the polarity,
Yeah.
then it's just negative.
Yeah, you can do that. But anyways, because I already pre-solved it doing counterclockwise, we're not going to. But you're welcome to try it.
No, it's clockwise. Like it's the same thing. You just pretend that it's going in the negative terminal, and so that it makes negative R1 IM1, which is what you wrote down.
Mm-hmm.
Since you have to flip the polarity, since it's given to us the opposite way.
Yeah, that makes sense. All right, everybody good?
With the on before.
On B4? Okay. So in this problem, I'm gonna say IM1. I sound IM1 and IM2 to be clockwise. Okay, which I'm always gonna stick for till the day I die. And where the current enters gives me the polarity of my resistor. Okay, so where is the current entering this guy? R4. Right, so I'm going to have this positive from my current perspective, right? From my Russell perspective, this is B4, which is the voltage from here to ground. And what he has as positive, it also happens to be the positive of my resistor. So that's why it stays positive. Does that make sense to everyone? Okay, so are we cool with B1 and B4? Okay, so now that we know that, now we can construct our MAME, right? So we have a how many by how many? Right. Oh, I don't want to put the answer there, so let me put All right, so look. Values. One. Okay, so this is 2 ohms. Okay, so who wants to give me the first mesh? Or the first entry? And then? Mm-hmm. Wow, that was hard. Okay, and then what's my right? Minus GM and it's gonna, I'm gonna go ahead and plug in the value for -2 and then plus IM2. And what else? All right, and then the next line. Okay, how do we feel about these? Sad, scared, happy, okay? Yeah, but we're almost there. Okay, so let's go ahead and split our. Are there any questions on how we got to this point? This is your homework. I mean, no, it's not your homework. Okay, so let's go ahead and split our things. And then what's this gonna look like? Yep. Mm-hmm. And then second line. Yeah, smart. Okay. And then what do we do now if we want to take it to the other side? Okay, so who wants to give me the first line? Mm-hmm. Mm-hmm. And then the second? Mm-hmm. And? All right, let's see if you guys did it. Yeah, good job. Okay. So now, remember, what was our goal in this problem? No. It was GAB, which is a combination of IA over EG, which happens to be IM2 minus IM1 over EG, right? So we still need to find IM2 and IM1, right? So you can plug this in your Inspire. You can put these guys as variables, just like call it E and G, and then tell me what you get. If you don't have an Inspire, I recommend you to get one for your first test. If not, you can learn Kramer's rule.
You don't know GM?
We don't know GM. No, that's part of the problem. Look at busy. All right. You got this guy. Anybody here doesn't have an Inspire for the first test? You don't have an Inspire? You don't? Okay, do you know how to use Kramer's rule? Okay, you better learn it because you're gonna need it.
There's also in his materials, there should be a document for Kramer's rule. I think it's materials 3. I would look at that as well.
I got VI.
Hmm?
I got VI.
It doesn't work. You need an Inspire, but I will say if you want to do it by hand, IM1 is delta 1 over delta times EG times negative EG or something like that, where it's not super hard. It's not really hard because wait, actually no. God, here. Where's my Kramer's rule? I'm just gonna tell you what it would be, but I'm not gonna do it for you.
Because we have technology.
Or you can ask Dr. Hoffaker to buy it for you. So IM1 is delta 1 over delta times negative EG minus delta 2 over delta times EG. So you can factor out the, oops, I'm giving it away.
Do you guys know what that delta is?
Yeah. So delta 1 is a determinant of 1, right? So you cover, what you do, you cover column 1 and row 1, and that's and you find the determinant of that matrix, but it's just the 1, right? So that will be here. And then something else you have to remember about Kramer's rule is that in a matrix, signs alternate, right? Positive, minus, positive, and then minus, positive, minus. So that's why this guy is negative. And so for that one, you will cover row 2, column 1, row 2, column 1. So that's GM here. And then over the determinant of the whole matrix, which you have to calculate by hand, is this times this times minus this times that, right? So it's a little bit of work. That, I mean, it's doable. You just have to learn algebra very well and be brave. And if you don't have a matrix, I mean, Inspire, you can take a picture of my Kramer's rule cheat sheet. All right, for those who do have the Inspire, did you guys solve it? What did you get for IM1? Yeah, it's gonna be a weird thing with variables.
Because we don't know what GM is.
Yeah.
2 times GM plus 1 over GM minus 6.
Yeah.
And for I2, it's 4 EG times GM minus 0.75 all over GM minus 6.
I think you got it kind of right. But that's the answer. It's probably the same thing. I just factored the EG because it's gonna be easier. For those of you who don't have an Inspired, these would not be too hard to get. Like I said, it's just algebra. So you can see here your 2GM plus 2. But anyways. Oh, okay. So anyways, now that you have that, just trust in your Inspire, or trust that you plug it in correctly. And if you did, then you can already solve for IA, which is, or you can even do IA over EG. And the thing about these problems is that EG is at some point going to cancel. If it doesn't cancel, you probably did something wrong. So that's what you want in the end. And then you combine that, blah, blah, blah. So you end up with this equation. And so what I like to do here, so we're trying to find GM, the ranges where GM or the whole GAV is either passive or active, right? This is GAV, this whole thing here. So again, what is the value of a resistor? It's a resistor over negative only if it's technically active, right? That would be the only thing that will make it negative. I mean, active. So if this whole result is positive, that means that we are passive or active. Yes, good job, guys. So if this whole thing is positive, then we're passive. If this is negative, then we're active. So what I like to do is take both the numerator and the denominator and set them equal to 0 and figure out what that value is. So if I set the numerator equal to 0, what's my value for GM? Right, because I have them on both sides, right? So give me GMs for both numerator and denominator. I divide by 2, that's hard. That's a hard one. What was the numerator though? Which is 2.5 and 6, right? So then what I do is I take these values and then I love to do these. Wait, I did it backwards. So now I have 3 values, right? But what I like to do is negative infinity to 2.5. That's one range. And then I have another range which goes from 2.5 to 6. And then my third range goes from 6 to infinity, right? And then I'm going to select values that are in between these numbers and plug them in and see what happens. So an easy number between negative infinity and 2.5. Thanks for not saying like negative 17.3. Okay. And then a number between 2.5 and 6. And then 6 and infinity. All right. Let me see if that's what I chose. Whoa, that was what I chose. Okay, so let's plug in 0. If I plug in 0, what do I get? Right, which is positive or negative? Okay, so between this region, I'm going to be passive. If I plug in 3, negative 1/3, which is negative, right? And then if I plug in 10, right, which is a positive number, right? So if I had done this on the test, I probably would have just looked at the top and be like, oh, what would make this negative? And forget about the bottom and forget that a negative over a negative is a positive. So that's why I like to do the 3 ranges. And that's how you can figure out your different regions for GM. Let's see that. Yep. Okay, so this will be the hardest problem. And I think that's because Russell doesn't know we have inspires. So for those of you who doesn't have an inspire, this might be your most tedious problem just because you have to do Kramer's rule. I will recommend 10 out of 10. Okay, so any questions in this problem? All right, everything worked out.
let's go back to something a little bit easier. So this is simplification. So we're going to be using source transformation and source dominance in this one, right? So he wants us to find the equivalent voltage and resistance from this circuit, from terminals A and B, right? So how do we start simplifying the circuit? So I think we should simplify this first. Can we transform that? Into what? Which side's positive? Okay. Then we have another source here. Then we have another voltage here, right? And then that just goes to whatever. So this is, what is the value of this voltage source? Yep. And then this is 4 milliamps. Okay, so now what would be left from this circuit? What dominates here? Exactly. So since the current source dominates, we can just keep that, ignore the rest. Right? So now we'll bring in the rest of it. So we have this current source here. Not this case, no. Then we're here, right? So what can we start doing here? I'm not tech savvy. Okay. So we can transform this, right?
Sorry.
So what can we transform that to? This, we have this. So we have a resistor. Does that value change? Nope. And then we have a current source. Which way is it going? What value?
Are you sure?
10 what?
It's taking on you.
10 milliamps. We have 10 milliamps. We have a 6K. We have a 2 milliamps going down. And we have 4 milliamps going up. Right? So what can we simplify this down to? So what are those values? Up or down?
Upwards, and then 2 kilo. And then both the source.
And then we transform it back. So does the resistance change? No. What is this voltage source? 24 volts. And that's it.
Wow.
Easy peasy. All right. What else do you want to work? That was on the homework. Oh, no. So this was a name, but you guys aren't going to have name on here, so I wouldn't worry about that. And then this is another passive active device, but since Monse just went over that, if you guys want to see this and just kind of work it out on your own later, you can.
Yeah, you can take a picture.
And if you want to ask us for the answers, we'll happily provide it. But yeah. Do you guys have any conceptual questions? Because that's the end of our problem session. Is there anything like you want to refresh on, any concept that you're kind of confused on?
I have just kind of a test question. That's kind of a two-part question. One, do you know who the grader is? And are they going, like, how much of the work is going to be graded? So, like, if we skip steps, are we going to be counted off of that?
I would try to put as much work on the paper as you can. But if you skip steps, I would like make a little note, because what I usually do is like if I put a bunch of stuff in my Inspire, I would like, okay, I put this in my Inspire to solve for this. So just make notes so they know kind of like your thought process throughout this problem.
And I don't know, the grader just graduated, so I don't know who's the new TA for. I know. No, so the same grader was me and Suzanne, and she was good, you know. I mean, she gave you no,
Suzanne.
it was the same for me and you.
Oh, yeah.
No, it was Priyanka.
Oh, yeah. Yeah.
We'll be here for another 20 minutes if you have any. But yeah, definitely nice graders. And I will say, I don't know, when I took electronics 1, the grader was different, but if you had the final answer correct, like, you know, he will give you the whole points. I mean, as long as you show a little bit of work, because in electronics it was like all inspired, you know. So
And has Russell explained to you how these like grades work in general? His bell curve? So during like these exams, there's gonna be an average and a standard deviation. So typically, if you're at the average, you're at a good place. You're like at a B or something. If you're one standard deviation below that average, you're kind of at a bad place. You're like C's, D's, I think, in that range. And then if you're one standard deviation above the average, then you're in a good place. You're in an A position. So if you get like a 57, but the average like a 30 something, don't feel bad. You're in a good standing with Russell.
yeah, it probably made an 8.
Yeah. So look out for the average and the standard deviation. Don't just look at the raw grade and be like, oh shit, like it's bad. Like my first exam, I got a 57, and that was one standard deviation above. So don't freak out when you first see it. And remember, throughout Russell's test, the most missed questions, he's gonna add those all up and put them on the final.
Mm-hmm.
So if you think, okay, this is over, I'm never gonna see this again, you will see the missed questions on the final. So I would just,
Like 5.
yeah, same, about the same. But yeah. Only work. Try your best. You guys got this.
Don't wipe your tears on the test. Wipe them on the test.
Any other questions from you guys?
Is it gonna be posted online on campus?
Yes?
Yeah.
We're gonna put it on YouTube, and if you guys know our HKN Teams channel, it will be there for a few days until like it expires, like 30 days, and then it will be in our YouTube channel. And if you need, you can scan that QR code to take you to our YouTube channel.
It's in the display box.
In
I
the
guess.
display box. But yeah, our Teams channel, you should be able to access it anytime. Let me here. I'll even put the code here because you just need to put the code. What's the code? Take one over it. No. Or maybe?
Since it's open book, open notes, like, do we get to use the laptop or like interactive?
No laptop, but open notes open. Like you can print out his materials.
And do we need the TI disease calculator mandatory?
You need this if you wanna put like that matrix we put if or you can just do Kramer's rule.
So it's TI 86, right?
TI, CAS.
Like which one do you recommend?
You guys need to scan QR
Just
code.
this one. You can take a picture. Make sure it's a CAS. What? How do you know our calculator? How do we know it's this calculator? It just has to say CAS.
Yeah, so CAS is the computer algebra system, so it can take variables and works problems with variables.
Thank you.
You're welcome.
Thank you.
Sure. Keep stuff recording.
And